Hi, this is Margo. This is Sunday evening, November the 20th, 2022. I hope everyone is safe and doing as well as possible. And we made it through another week. We're just plugging along. And I'd like to welcome everyone to the show tonight. This will be my weekly update that I'll be putting on YouTube. We're going to go over climate-related items for the week, and methane, and sea ice, and some earthquakes. And so we're going to start with Climate Reanalyzer. Now, last week, I showed a couple of things. I showed on Climate Reanalyzer how they changed their website, and it's not that much different, but it's just, it is a little different. And I also showed on the NOAA methane data where we're tracking that now. It's on a different website, and we're going to look at the NOAA data tonight too. So we're starting with Climate Reanalyzer just to get an overview, and here we are for today with maximum temperatures around the world, and see from Canada up across the Arctic Ocean here, and a lot of Russia. See, it's in the purples. So that's getting pretty cold. Like the bright purple is minus 30 C as the actual temperature. There's this area over the Beaufort Sea that has been a lot warmer than normal this week, and we've actually had melt going on in the Beaufort Sea ice this week. And I'll show y'all that. Here's the flat view, and see the whites here in South America and southern part of Africa, Australia, and the whites are about 40 C or higher, or 100 degrees Fahrenheit or higher. And you can see all these cooler temperatures have come down over Canada and the US and Russia and so on. Here's 2-meter temperature anomaly, and here's the red over the Beaufort Sea. See that? And right now it's about 18 to 20 C higher than normal. And this has been all week like this. And see, it's warm coming down into Canada and Alaska. Then we've got blues right next to it. Then Greenland, you're in the brown, and the North Atlantic, and coming up into the Arctic, you're in the brown. And then we've got blue, which is colder than normal, coming across from Canada across to Ireland and the UK there. Here's the flat view. Europe, excuse me. Europe, you're finally cooling down. It's been in the browns here for a couple of weeks, and reflected in the methane readings there too. See, here in the US and Canada, we've got deep blues from Texas up to the Hudson Bay, and the deep blue is about 10 to 14 C lower than normal. And on this model, they put the overview down here at the bottom. And so if you do save as on the picture, you don't get the overview. You got to do that as a screenshot. So worldwide, we're up 0.37 C, higher than normal. The northern hemisphere is up 0.58 C. The Arctic is up 3.26 C, higher than normal. The Antarctic is down 0.49 C, that's lower than normal. Southern hemisphere is up 0.16 C, and the tropics are up 0.17 C. And then precipitation and clouds. Got rain coming up in this North Atlantic up to the Greenland coastline, and National Snow and Ice Data Center has shut down their reporting on Greenland until April. So I'm thinking there could be some melting going on, but their model shut it down and for the winter. So I'm thinking they're going to need to change that if this keeps up. Here's the flat view. This big swaths of rain coming across. Look at all this rain over the Gulf of Mexico. And then here's what used to be the jet stream. I call it the jet loops now, and see the breaks. That's where the cold air is swooping down. Here's the flat view. Now, I've been talking about how these loops are getting moving more towards the equator. The ones from the northern hemisphere are dropping more south, and ones in the southern hemisphere are inching up more north, and they're actually meeting, it looks like. And for instance, here's a loop here right at the equator, and see it kind of goes down and up, and then here it is in the northern hemisphere. So it's actually interchanging here, and I think we're going to be seeing more and more of this phenomenon happening. Who would have thought that the jet streams would be merging? I mean, that just doesn't make any sense, does it? But that's what it looks like is happening. Big breaks, anyway. We'll look at sea ice and snow cover in a moment. And here's sea surface temperature anomaly. This is for yesterday. We've still got browns and reds here in the Arctic, around this Russia coastline and Norway, Iceland, Greenland. Here in the Chukchi Sea is still brown. And what was this blob here off the coast of Newfoundland has now kind of spread out along the eastern seaboard of the U.S. And we can see the light pink, that's the highest. That's 6C, higher than normal. And then all these browns from the Gulf of Mexico all the way across the Atlantic. Here's the flat view. Mediterranean is still really heavy with the browns. And also the Baltic Sea, North Sea, Black Sea, Caspian Sea, Red Sea, Persian Gulf. They're all pretty warm there. And see, it's heating up on this west side of southern Africa. And here's the Pacific view. Here's our blob in the kind of the middle part of the North Pacific. It's cooling down a tiny bit, but it's definitely a blob. We're getting browns around Kamchatka and reds coming in around Japan again. And then these browns in around Indonesia and coming all the way across to South America. And in the Tasman Sea, that's heating up. And that's this area between Australia and New Zealand. And it's moving into their summertime. So things are heating up down under. And we'll see this heating up more and more there. And when they redid the website here, they took away the overview, and I'm not happy about that because, you know, we don't have a planetary-wide overview with actual numbers anymore. Just the chart. And anyway, so that's what we've got there. Now last week, remember I showed that the NOAA methane is now being reported off of this other part of the website, and it's called the HEAP model. HEAP, and it stands for, I don't remember what it stands for, and it's an acronym, but this is where we get the methane data now. And we've got two satellites, METOP-B and METOP-C, so we have data from two satellites instead of one now. And so I'm tracking the 487 millibar reading, which is as close as we can get to 500 millibar, which is one of the readings we look at on CAMS. And I'm also tracking the 1000 millibar reading, which is surface level, considered surface level. And we had morning and afternoon for each of these, and for METOP-B and METOP-C. So we end up having, for each level, we have 4 readings for each level. So I'll show you. I was able to plug in the data. Oh, one more thing I wanted to show. To change the date, you just click on that little down arrow. Here we are in November. The latest is the 19th, yesterday. And their data started, see, nothing in September, started in October, and the first day of data was October 28th. Let's see, I just did it trial and error. See, it says image unavailable. on the 27th, and it was the 29th or so when the other data was no longer available. And so this is where we're tracking this now, and see the chart or the image looks, everything is the same except it's just a different level, and 2 satellites instead of 1 now. So let's go over, and I've downloaded all of the data from the 28th to yesterday, and I've plugged it into my spreadsheet, and we're going to look at that tonight too. And now I'm to the point of now tracking this and reporting on it daily, and we'll continue to be able to see trends with the methane. So we're starting over, but we'll still be able to see the trends. So here we're looking at the NOAA methane data for yesterday, the 19th, in the morning, and this is the Met-Op-B satellite, 1000 millibar level. The mean or average was 1841 parts per billion, and the high reading was 2159. And so we still have this color ledger down here, see, and that hasn't changed, and this pink area is between 2000 parts per billion and whatever this high number is here, which is 2159. And we notice that these numbers are quite a bit lower than what we were seeing on the 469 millibar, and it's because this is closer to the surface of the Earth, and methane gathers higher up in the atmosphere, so you're going to have higher readings as you go up in the atmosphere. And here we are in the afternoon. The mean was 1841 again. The high reading was 2167. And here we're to the Met-Op-C satellite in the morning. The mean was 1845. The high reading was 2178. And in the afternoon, the mean was 1845 and the high reading was 2114. And here's my spreadsheet. I just added pages onto my old spreadsheet, and here we're tracking the let's go to the daily. Here's the daily tracking. So for the 19th, the average came out to be 1843 parts per billion, and that was a decrease over the day before of 1.25, and we went down this week 2.25. So here's where we started on the 28th at 1843, and then the 29th it was 1844, and then for the first week, okay, we can see the numbers here. It was just kind of going up and down. The highest that week was 1847.25, and then it started going down, and here on the 5th it was 1843.75, So an overall decrease that week of 0.25. And then the next week, it went up. You can see, okay, so it went down 1.25 on the 6th, and on the 7th it went up 1.0. On the 8th it shot up 2.75, and on the 9th it went up 0.25. On the 10th it went down 1.0, and on the 11th it went down 0.25, and no change on the 12th. And so on the 12th, that was the Saturday, the weekly reading, we were 1845.25. That was an increase that week overall of 1.5. But at one point, we were 1846.25. And, supposedly methane is on the downswing. We peaked out in October, so supposedly it's on the downswing. So we really don't want to see it going up like this. That's unusual. But again, we're in no man's land, so really anything could happen. So here's what happened this week. So here it was for the 12th, and then the 13th, it went down 0.75. On the 14th it went down 1.0, 15th down 1.0, 16th down 0.5, 17th it went up 1.5, the 18th it went up 0.75, and on the 19th it went down 1.25, giving us an overall decrease this week of 2.25. And that's more in line with what we're used to see. We're used to seeing when we're on the downswing. And so here, and I haven't made the chart yet. I'm going to wait until we get a few weeks out, and then we'll watch it going up and down. And so here it is, the weekly chart, where it went down 0.25 the first week, and the second week it went up 1.5, and now we're going down 2.25. Now I wanted to show, okay, so that was surface level, and let me do this. Wait. Oh, here we go. On our Met.1, the one that we've been tracking on. See, we peaked out here. This is the 477 /469. I think it was really 469 millibar. It was the image you clicked on was the 477, but then when it came up it said 469. Anyway, we peaked out here on October the 13th at 1951, and see, it went up that week 2 parts per billion, with it ending on the 15th, and then the week of the 22nd it went down 0.5, and here we ended on the week of the 29th where it went down 4.0. So that was a big drop in 1 week. We can see right there. And so we're in the period where methane should be going down now. And I just stopped. This is where the last day we actually had good data here was the 30th, and it was the same as the 29th. So I'm not even, we're not even going to count that. It was all the same. And so that's the end of this model, really on the 29th and the 30th. And then we're picking up here on our new model on the 28th. So there's that. Now let's move on. Now we'll look at the 487 millibar reading, and this should be closer in comparison to the 500 HPA on CAMS than what we were seeing on 469, because this is closer to the 500. Okay, for yesterday the 19th in the morning on the Met-Op-B satellite, the mean or average was 1918 parts per billion. The high reading was 2423. In the afternoon, the mean was 1919. The high reading was 2470. Look at this, Met-Op-C. Look at all this pink. The mean was 1887. The high reading was 2179. And that's that highest range. Let's see, from really covering the Arctic there. And in the afternoon, the mean was 1886, and the high reading was 2208. And again, we can see it's really heavy over the Arctic. And so, we'll move on over to our daily chart for 487. And, oh no, this is, wait, gotta get this back. Okay, here's our weekly chart. So the 19th averaged out to be 1902.5 parts per billion. That was a decrease this week of 1.75. Now here, we saw the same trend at 487 as we did with the 1000 millibar. That first week we went down 0.5. The second week we went up 2.75, and third week we went down 1.75. So, it's a little bit different depending on the millibar reading, but the trend is the same, see? So, let's see what happened. So here's where we started. On the 28th it was 1902.5. And we're starting though with this 1902 here, what we're starting with on the 29th, and then it went up 1 on the 30th. On the 31st it went up 2 parts per billion. On the first, no change. On the second, went down 1.5. On the third, no change. On the fourth, it went down 1.5. And on the fifth, it went down 0.5. Ending at 1901.5 that first week, with a slight decrease of 0.5 overall. And then the second week, on the 6th, it went down 1.0. On the 7th, no change. 8th, 1.25. 9th, went up another 1.25. On the 10th, no change. On the 11th, it went down 0.5. And on the 12th, it went up 1.75. Ending at 1904.25, and for that week we ended 2.75 higher for that week. So again, we're in no man's land. And then this week, okay, the 13th, we went down 0.25. 14th, down 0.25. 15th, down 0.5. 16th, down 0.25. 17th, down 1.25. And the 18th, up 0.25. And the 19th, up 0.5. With an overall decrease this week of minus 1.7 or 1.75 decrease, ending at 1902.5. And so for most of the week it went down, and then the last 2 days it went up a little bit. So this is what I've got so far, and I just wanted to share that with y'all here on my weekly show. And so we've got all the data with the start of this new model, and then we'll go day by day now. And if you'd like to see day by day reportings on methane, I do that on my Subscribe Star page, and the link is in the description box below if you'd like to join us over there and help support my work. So there's that. And so we're going to close that out. And now we'll look at CAMS for Saturday the 19th. Arctic view at surface level. Now CAMS did some weird things this week. They would go a couple of days without updating anything, and then they'd update everything instantly, you know, but I was able to track it and get it all recorded. And they were also slack on reporting all these others on this left side on a daily basis, including sulfur dioxide, ozone, nitrous oxide. Is that what that is? Nitrogen dioxide, formaldehyde, carbon monoxide, carbon dioxide aerosols, and UV. All of these, but they're current now. So as soon as they go current, I start recording the data. So here we're going to look at Saturday surface level. So the data is for Saturday, and the forecast period is Sunday through Wednesday. And look how this methane is going to be really heating up in the forecast period. Look at this wave come up here. See, there it comes by Tuesday and Wednesday. And the Scandinavian area, see, it's coming back to life. Here's Russia. This interior of Russia is heating back up. And here Komsomolets is still billowing. Should we call this hemorrhaging or billowing? I think it's at the billowing stage. We saw it earlier this year where it was massive, hugely coming up, and that was hemorrhaging. So, and we've still got this hot spot in the North Kara Sea too. That's billowing. And see the orange or yellow coming up. This is coming up through the sea ice, by the way. And our main background color up here across the Arctic Ocean, it's not really green, it's more of this yellow green, and that's about 2,000 parts per billion, or green yellow. And then the yellow green, this one, that's 2020. See, these higher readings, they're coming up here in the Laptev Sea through the sea ice. And the reason we see this happening, I read on, from Sam Carana and other places, is that after the warm up and then the refreeze, you get a little skim of ice coming across, and the water underneath is still warm, but there's a little skim of ice on top, and the seabed is, the heat can't escape through the sea ice, and so it's trapped under that little thin layer of ice, and so it's actually heating things up underneath, and the seabed is warmer, and that's why we see higher methane readings up here until things kind of cool down. So there's that. And now we'll go to the North Pole view. Here we can see the whole northern hemisphere. And see, it's still pretty black or blobby from Germany over France. Well, France pretty heavy starting out. Let's see, this is still very heavy. I mean, that's heavy like China, and you can see China is just solid now, filling back up, streaming over the coastline. See, That's very high methane when you see that happening. Here's India, and see it streaming over the Bengal Bay with that highest readings. And Sri Lanka, you're covered up. Here's the Persian Gulf. And look at the US. Man, that's like solid blob. Watch. Here it comes. There. Look at that. That's on Tuesday, Wednesday that it's filled up. California, that's filling up down through the state and streaming over the coastlines. So all of that, I mean, we're under the dome. Look at these waves moving out. You can see waves moving off of Mexico and Central America. See, moving west there across the Pacific. Okay. Now we'll go to the global view. This darker blue around the equator and south, that's 1840 parts per billion. So that's and it had been mainly 1860, this color, but it's going down first of all around the equatorial regions. And then see the next color down here is 1820. So it is going down in the southern hemisphere. It doesn't look like it's going down to me in the northern hemisphere though. Okay, now we'll look at 500 HPA. So this corresponds with the pinks, with the area of the pinks that we saw on the NOAA data. See, very heavy. But we do have spots where it's lightening up a little tiny bit. We've got reds though coming further south, see, here in the Pacific. And then total column. And this is where they add up the methane through all the different layers for the highest readings. China has the highest here. A little bit of Japan. Then we've got next color down, this dark red, here over Europe and eastward. Look at all these reds across the Arctic, Pacific. So there's that. Now I'll show you just a couple of other things from CAMS. This is sulfur dioxide today, and this is total column. Now this, look at this release off the coast of North America. Well, actually, California, well, the Pacific Northwest. I'm thinking this is from plate movement, with the Juan de Fuca plate moving. And this is, these are volcano related in Mexico, South America, and so on. Here it is at 500 HPA. Now, see, this is in Colombia. The Reventador volcano is there. This is Popocatépetl in Mexico. And look at this area. Maybe we'll go back to CAMS and look at that. It's this whole west coast. And I'm wondering if this is like a forerunner of seeing this subduction zone do something. Let's go to today. Actually, let's see. Yeah, sulfur dioxide. See, it wasn't there yesterday. And let's go to North America. And now let's go to today. Look at that. Yeah, this is, that Juan de Fuca plate is just off the coast here. I'm thinking this is plate movement. So, I'm thinking that's not a good sign. Let's go back. Let's see if anything showed up on Saturday here. Here, we gotta rewind. So let's see if anything happened on Saturday. No, not really. It came up on Sunday. And so that was a sudden thing right here on Sunday. See? And this is total column. Let's look. Here's surface. We might not see nothing at surface level. Here's 850 HPA. See nothing. So it shot up higher in the atmosphere. 500. When you see plate movement, look at that. Yeah. That, look, it's just all along. So that is definitely plate movement there. So if we look at earthquakes, and we've been having movement on this Juan de Fuca plate this week. But that sulfur dioxide is just, it's on the east side of this line. See, it's this plate that's moving. So I'm wondering if that's the subduction zone fixing to go. Look at that. See? Yeah. So that's that's the most disturbing thing I see here, and it looks disturbing to me. And see, here's 300 HPA, no big deal. So we're going higher up in the atmosphere. Really nothing there at 50. So it's the most. We see it at 500 HPA. So that's sudden movement with it shooting up like that all along. That's the whole plate, the whole edge of the plate from California. This is the Bay Area here, all the way up to Vancouver, Canada. So usually we see the sulfur dioxide first, and then the plate movement or earthquakes, or this is earthquakes, it's not volcanoes. It's just right along that line. So that could happen in the next day or two. But that's really, really kind of astounding to me. It's just so distinct there. Oops. So there's that. Okay, so let's go back here, and we also have this is Kamchatka. They've been having earthquakes and volcanoes there, and so on. So here's the ozone hole over the Antarctic today, and the sun is up. We can see it shrinking down, and it's only 3 layers down in the danger zone. So it's thickened up. Now we're only 3 layers down. Here's the Arctic ozone today, and we're seeing aqua. So this is a hole over Greenland, all the way across Svalbard, all the way to Norway. And then we've got greens over the western Canada and US there. And see the reds coming in? That's heavier or thicker ozone forming. Here's the global view. And we've got aqua here in the mid-Atlantic. Also coming in over the Pacific, just south of Japan, all the way across to, this is China here. So it's a pretty large band of aqua. Then all these greens. That's all of those. Now we'll move on to sea ice. And this was another one of the pages that Climate Reanalyzer changed. And here the white on land is at least 1 centimeter of snow or more, and then up where you see the kind of bluish white over the ocean or water, that's ice. And what we're seeing here, this is for today. you can see where it's melting here in the Beaufort Sea, and that's from that warmer air that's been over the Beaufort Sea all week. And the Chukchi Sea there. And it had frozen more solid, but you can see the darker colors coming in. Here's the Baffin Bay. Here's Hudson Bay, a little bit forming. Not much change on this east side of Greenland. We've been seeing rain come up to this east coast several times this week. Svalbard is still open. We can see it inching out in this North Barents Sea, and this North Kara Sea is filling, and it's coming down along this east side of Novaya Zemlya. And we can see there's ice all the way from Canada over to Russia now. So let's see what happened this week. Here we are last week in our show, and see how nice and concentrated it was in this Beaufort Sea last week. See? Nice and concentrated. Not like that today. So here it was Sunday, so I'll just click through. Here's Monday, Tuesday, Wednesday, Thursday. You can see the melting happening around here in the Chukchi Sea. Friday, Saturday, and then here's a big change here today. See? So there's that. And now we'll move on to our other models. Here's the U.S. Navy model of Arctic sea ice thickness. This is for today. And it's thickening. You can see where it's going to darker purple here and darker, and then that moves into blue as it thickens up, the dark blue, and as that thickens it moves into dark aqua, then that moves into brighter aqua, then into green, yellow, and reds. Very little red, just a couple of places here along the Greenland coastline and here along Canada. And you can see the fringe inching out where it's refreezing. This matches up with Climate Reanalyzer here. Novaya Zemlya, and here's the Baffin Bay, Hudson Bay. Here are these tributaries. They're thickening into more aqua colors. And here, there's the Beaufort Sea. So we've got a little green down here, just above Canada. And it's still open here in the Chukchi Sea. Here at the Bering Strait, it's inching across. So, here's the 30-day animation. This was updated to yesterday. So the data goes back 3 weeks, and forecast goes out to next Saturday. So let's see what the model is saying. So if we look at this upper part first, here you can see it. Here it's coming back in the Kara Sea. And it's kind of this invisible line where it's not crossing here on the east side. And this aqua part, that's what was left of the thicker sea ice from this year's melt. And I don't see a lot happening with this refreeze, with the thickening. I mean, it's just so slow. Okay, moving on. This is the Beaufort sea ice thickness for yesterday, the 19th. See, here's the little red lines right along the coast. And that's 4 to 5 meters thick. The green is 3 meters thick. The bright aqua is 2 to 2.5 meters thick. This darker blue, that's about 1 meter thick, 1 to 1.25. The darker aqua, that's about 1.5. And then the purple, the dark purple is about 1 meter thick. And then where you see it going into lavender, it's thinner. Where you see the white, that's where it's open water mixed in. And here's the 30-day animation. And this was updated to yesterday. So the forecast goes out to next Saturday. Watch it move in here. That's where it started melting. See? It was this week where you see it going back and forth. So there's that. It's just kind of holding. Here's the Antarctic today. And see these white spots? That's open water. And this east side is melting quite a bit. And it's thinning down all the way around. Here's the 30-day animation, again updated to yesterday. So the forecast goes out to next Saturday. So we can see that the melt is on now. We're seeing the extent shrink down in addition to it thinning out quite a bit. I mean, it's noticeable. See, there's almost no ice here on the southeast edge by the end of this model by next Saturday, see? And see, it's melting around the coastlines here the Ross Sea, and so forth. There's that. And here's National Snow and Ice Data Center, Arctic sea ice concentration for today. And see the darker blue. That's where it's melting, here in the Beaufort Sea mainly. And out here, where you see the dark blue, that's the refreeze. Same thing here in Baffin Bay and Hudson Bay, but here, this had been solid, almost solid white across here. And here's the refreeze on the extent. This blue line is this year, the dotted line is 2012, and we can see it's kind of falling down a tiny bit. So it looks like the refreeze is slowing, and we're probably going to meet up with 2012 in the next couple of days. Here's the Antarctic. See all the darker blues. High melt. Definitely high melt there. And here's the refreeze. I'm sorry. This is the melting. This blue line is this year. This greenish line is last year. And so we've crossed last year, and we're still melting, but at not as fast a rate as last year. We're still about even with last year. That's all of those. Okay, next. Before I go, I've got an article I want to share. It's actually about the Antarctic, so we'll look at the Arctic first with sea ice, and then we'll look at the article, and then we'll look at the Antarctic. So here we are today. This big black circle, that's where it's dark now. We can see all the coastline in the Arctic here. That's now in the dark. Most of Greenland is in the dark. This Russia coastline, that's all in the dark. Alaska, you're the top half, you're in the dark. Canada, all the archipelago is in the dark. Up to Norway and on across. Now, let's turn on our sea ice concentration layer and see the colors here. This is because it's melting. It had been more solid. So let's go back to last Sunday. See the solid white here last Sunday. And we'll just click through. So here's Monday, see it's still solid. Tuesday, Wednesday, Thursday. Okay, you can see it melting here. And these edges are melting in. Here's Friday, here's the melt coming. Look at Saturday. See that? It's definitely melting. And here today, still melting. The white means that it's solid ice. And even with the pink, it means that there's breaks, the cracks, and there's some open water. So the concentration is not as much. So there's that. Now, we'll turn on our nighttime layer, see what we can see. Sometimes it's really easy to see stuff here. Other times this model just doesn't work. Here's Greenland, and we can see it's really dark here. I can see there's broken up there in the Lincoln Sea. Here's the nearest strait. This is really too dark to see that much. Let's go to yesterday. Same kind of thing. We still have it's just pieces of ice in the nearest strait. Here's the Baffin Bay, and here's the sea ice on the edge here. And here's this east side of Greenland. Here's the ice coming out there. See? Here's Svalbard. Here's the ice. It's inching out. Here's Franz Josef Land. Here's Novaya Zemlya. Okay, here's the ice in the North Kara Sea. And here's see these jagged lines. The data comes in at different times, and so depending on what time it comes in, you'll have an overlay from one to the next. Here's Severnaya Zemlya. This is the area where we're seeing methane billowing. And here are big cracks still in the ice. And here's the North Kara Sea. Here's Russia. Here's the Laptev Sea. Can't see anything with the model up there. Let's go to yesterday. Let's see. Can't see much. Lots of weird lines. Okay, here's the ice. See the cracks. There's New Siberian Islands. And moving over, here's the Bering Strait. See, this is ice here. Here's the Chukchi Sea. Here's the ice way over here. So this is open right now. Can't see much. There's Barrow, Alaska. And here's the Beaufort Sea. So it's right in here. that it's melting. Can't really see much. Here's Canada and Ellesmere Island, and we're back to where we started from. So we couldn't really see much there. We try. Alright, now next I'm going to share this article. This is from NASA Earth Observatory, and this is a recent article about our iceberg we've been tracking in the Antarctic, A-76, and it's in the, they're saying it's in the Drake Passage now, so that's why it's spinning kind of back and forth. And okay, this article was from October 31st of this year. In October 2022, a clearing in the clouds revealed a huge geometric piece of ice floating in the Drake Passage. This is Antarctic Iceberg A-76, the biggest remaining piece of what was once the largest iceberg floating in the world's oceans. The berg is visible in this natural color image acquired on October 31st with the moderate resolution imaging spectroradiometer, or MODIS, on NASA's Terra satellite. Notice the iceberg's long tabular shape is distinct from sea ice further south in the Southern Ocean. The iceberg's parent berg, A-76, broke from Antarctica's Roni ice shelf in May of 2021. At the time, it was the largest iceberg anywhere on the planet. Within a month, the iceberg lost that status when it broke into 3 named pieces. The largest of those pieces, iceberg A-76, now drifts nearly 2,000 kilometers or 1,200 miles away in the Drake Passage. The passage is a turbulent body of water between South America's Cape Horn and Antarctica's South Shetland Islands, including Elephant Island, visible in this image. So here it is, way up here. Here's the Western Peninsula, and if we go to the Antarctic, it's right out here. See, I've been showing this all the time. It's right there now. But this is now considered in the Drake Passage as it's leaving the sphere of Antarctica. And if we look on Google Earth, I'll show you too where this is. You'll get a different, another perspective on it. So here's South America, here's the Western Peninsula. It's right up here. This is Coronation Island, and I think this is Elephant Island. So it's up here. And so the Drake Passage is right along here. And it's very turbulent, so it could break up potentially And we've been seeing pieces break off there. So let's get back to this. Despite the long journey, the iceberg's size remains remarkably unchanged. In June 2021, the U.S. National Ice Center reported that A-76 measured 135 kilometers long and 26 kilometers wide, a total area equal to about twice the size of London. In October 2022, USNIC reported that the berg maintained the same dimensions. It remains to be seen where A-76 will drift next. It is already more than 500 kilometers north of its position in July 2022, when the European Space Agency's Sentinel-1 satellite showed the berg passing the Antarctic Peninsula. Sentinel-1 satellites carry synthetic aperture radar instruments which can observe surfaces even in the darkness of austral winter. As they continue to drift north, icebergs are usually pushed east by the powerful Antarctic circumpolar current funneling through the Drake Passage. From that point, icebergs often whip north toward the equator and quickly melt in the area's warmer waters. So I'll leave a link below if y'all want to look at this. And this is the most recent information I found about A-76. And so here it is. And here's the Western Peninsula. The sea ice is over here. See, it's by itself out here. These are clouds. So let's see what it did this week. And remember last week we were showing it rotating so fast. Here we were last week. There's the 13th. Here we go. Here's the 14th. See, it's moving, rotating counterclockwise. 15th. 16th. Look at it. 17th. That's a good view. I wanted to show you here. See these white pieces? These are pieces breaking off from it. See, it's kind of jagged on this east side. That's where pieces have been breaking off. Okay, let's keep going. There's the 18th, 19th, cloudy, and here we are today. So it's about in the same position, but just rotating right now. So there's that. Here's the Western Peninsula. Here's the ice. This is the Weddell Sea. See how this is melting in. There's the ice. Here's the Larsen ice shelves here. And this A-76, it broke off right in here. That area, that rectangle. May 2021. Okay, coming on down. Next stop is Pine Island Glacier. Right here, this is an excellent view. You can see the flow. Here's some open water. And this is where it had calved off a couple of years ago. And then this is where it refroze. But there's a hole there. And I'm thinking this tongue is gonna, or this shelf, I'm thinking this is gonna melt. Look at this. Next stop, Thwaites Glacier, or Doomsday Glacier, right here. These are clouds, but this is it right here. And look at this. All that open water. This is where the tongue is broken off. It's just attached right here. And see, it's getting wider. This hole is getting a lot wider. We're starting to see open water. This is melting, coming apart, and the tongue goes way down here. And see the pieces that's coming apart there. Okay, let's come on around. Look at all this open water coming on around. Open. Next stop, the Ross Sea. Here's the Ross Ice Shelf. Here's the Ross Sea, and see open water right along the ice shelf there. Here's the sea ice. Here's Ross Island. There's a cloud there. Here's yesterday. Mount Erebus. This is the shadow. And here's McMurdo Station. And here's the ice melting. See? This is an excellent view. An outstanding view. Look at this, no clouds. So there's the ice in the Ross Sea. Let's come on around. Here we are today. Look at all the clouds. Next stop, Totten Glacier. And can't see it. There's a big cloud there. Cloud. But we can see some open water. Here's the melting. That's the 17th. Here we go. Here's the 16th. See the open water. Here's the tongue. Open water. Here's the ice. And this is melting. Okay, let's go back to today. Come up the east side. Here's the ice. Not much, huh? Look at all this open water. Next stop, Amory Ice Shelf. Here it is. These are clouds. Yesterday. Here's the 18th. This is a good view. See, open. And here's the Amory Ice Shelf. There it is. Here's the ice. See? Open. Okay, let's go back to today. Coming up to the north edge. See? Open near. Then next stop is the Brunt ice shelf right here. Here's today. Here's yesterday. See, it's open around it. Here's the 18th. Look at that. Look at that view. Now this is an area where we see methane coming up. Whenever the background layer gets low enough on CAMS, we'll be able to see methane coming up here through the cracks. See? There's open. A lot of open water right around the edge there. And we're back to the Weddell Sea. Here we are today. And let's see. We're starting to see a lot of open water form in between all those pieces. So it's about to be in high melt down here. So there's that. Next, earthquakes. Okay. 240 in the last 24 hours. These bigger dots are 5s. Here's 5.0 Papua New Guinea, 5.1 Kupang, Indonesia, 5.5 Fry, Greece. These are 4s, lots of 4s. What's going on up here? Look at this. This Mediterranean is active. We've got 4 here. Look at this. 4.1 Northern Algeria. Look, 4.7 Margo, Greece. Italy. We've been seeing earthquakes there. 4.3 Ambalokipoi, Greece. And there's the 5.5 Fry, Greece. That's active. Here's one in the middle of the Atlantic, 4.8 Azores Islands, and so on. Now, let's go 7 days, all magnitudes. So here in the last week, we've had 2,249 earthquakes. We've had some Arctic earthquakes. Here's one in the Baffin Bay on the Canada coastline, 4.5 near Clyde River, Canada. This came in on the 19th at 2:24 in the morning Pacific time. And We also had one here in the Beaufort Sea, 4.1, also on the 19th at 11:11 in the morning. So remember, this is the area of where the air temperature is so much warmer than normal, and we're seeing melting of the sea ice. And then here's a couple, 3.0 Koktovik, Alaska, and 3.1 Arctic Village, Alaska. These are Arctic earthquakes. Look at this. We had one in the Bering Strait, 2.6. And lots of activity. Okay, here's Kamchatka. See, 5.0 there. Coming on around. We had 6.1 south of the Fiji Islands. This came in on the 13th at 9:04 p.m. 627 kilometers deep. So with it large and deep, that causes plate movement. Look at all of these. This area, 25 this week. Trying to just get the biggest ones. 5.8 Solomon Islands. 5.0 Solomon Islands. Okay, Sumatra. You had activity this week. 6.9 was the largest off the coast of Bengkulu, Indonesia. This is the island of Sumatra. This happened on the 18th at 5:37 in the morning Pacific time. Look at all of these here. 10 here this week. But that was the biggest one. And Japan, 6.1 off the coast of Toba, Japan, 357 kilometers deep. This came in on the 14th, just after midnight. Here's one in Russia, 4.3, just northeast of the Baikal Sea. Mongolia, next to Russia, 4.3. Here's another one, 4.4. Belyashi, Russia, and so on. So, look at all this. Let's go, okay, and see all along this east side of the Pacific. All these plate lines, lots and lots. Now, Texas. Texas, you had 98 this week. And the largest was a, here we go, 5.4 near Mentone. This came in on the 16th at 1:32 in the afternoon. So that's a lot, 98 in Texas this week. And this is an area where we see heavy methane. Well, a lot of drilling, fracking here. Massive amounts. Here's Oklahoma. Here's some on the New Madrid zone. And up here we had a 32 here in southern Idaho. So that was kind of a cluster. 3.6 was the largest. Then, let's see, here's Pacific Northwest. Nothing huge. I forgot 49 right here. Well, it's actually more, but you get the idea. Look at this. All around Mount St. Helens. See? 18. Look at these right in the crater of Mount St. Helens. So, here are the ones on the Juan de Fuca plate. 4.5, that was the largest one on the 18th at 7:42 a.m. A 3.4 on the 19th at 4:21 a.m. 2.7 on the 20th at 3:32 p.m. and a 2.0 on the 20th at 4:50 p.m. So remember the sulfur dioxide we saw. It came straight up, all the way up. So plate movement. So I expect to see more earthquakes in this subduction zone. And also, now this was interesting this week. Look at this at northern Nevada. 14 here. Um, 2.1 was the largest. Right on the border between Nevada and Oregon. And we also had some more movement out here east of Pyramid Lake. See, here's a cluster of 9. Lake Tahoe, see, showing up in the lake, and so on. Look at all this, and it's just all spread out. And then coming up, this whole west coast, see, just solid. So, that's my report for tonight. I do believe we're in the end times. Uh-oh, look, here's a new one. 5.2, Izu Islands, Japan region. 416 kilometers deep. And I'm going to do the Bible reading in a minute, but I just want to talk for a second. And I just can't believe how fast this year has passed, what all has happened, and, you know, it's just going faster and faster for me. It's not easy. I mean, this has been a really rough year for me. And I know it's been rough for a lot of people, but we're coming up to Thanksgiving, and I'm thankful for all of you who are here with me on this journey, who are interested in what's going on with the planet and, watching as I document all of the changes that we're seeing here at the end. And we're really in no man's land with the methane and the sea ice and everything. And the more they try to mitigate things, the worse it gets. So, I think we're past the point of no return. And I do believe that Jesus is coming. I do believe in the Bible and that we are in the end times. These times have been prophesied of by Jesus and other people in the Bible. And we're seeing things that he said we would see in the end times. And so I'm a watch person on the wall, watching and waiting. And as things get more chaotic, the more I believe we need to just be still and tune in to God and Jesus and just hold the energy of peace in our hearts and all around us, and so that we can be a pillar and we can be a rock of stability for the people in our lives. And that's what I want to be for all of you. I want to be a pillar of stability here. And this is why I'm here every week reporting. It's not good news, but I'm here because I love you and I care about you. And now, let's move on. And we're reading out of the book of Job. Job chapter 9. Then Job answered and said, I know it is so of a truth, but how should man be just with God? If he will contend with him, he cannot answer him 1 of 1,000. He is wise in heart and mighty in strength, who hath hardened himself against him, and hath prospered, which removeth the mountains, and they know not, which overturneth them in his anger, which shaketh the earth out of her place, and the pillars thereof tremble, which commandeth the sun, and it riseth not, and sealeth up the stars, which alone spreadeth out the heavens, and treadeth upon the waves of the sea, which maketh Arcturus, Orion, and Pleiades, and the chambers of the south, which doeth great things past finding out, yea, and wonders without number. Lo, he goeth by me, and I see him not. He passeth on also, but I perceive him not. Behold, he taketh away. Who can hinder him? Who will say unto him, What doest thou? If God will not withdraw his anger, the proud helpers do stoop under him. How much less shall I answer him, and choose out my words to reason with him, whom, though I were righteous, yet would I not answer, but I would make supplication to my judge. If I had called, and he had answered me, yet would I not believe that he had hearkened unto my voice. For he breaketh me with a tempest, and multiplieth my wounds without cause. He will not suffer me to take my breath, but filleth me with bitterness. If I speak of strength, lo, he is strong. And if of judgment, who shall set me a time to plead? If I justify myself, mine own mouth shall condemn me. If I say, I am perfect, it shall also prove me perverse. Though I were perfect, yet would I not know my soul. I would despise my life. This is one thing, therefore I said it. He destroyeth the perfect and the wicked. If the scourge slay suddenly, he will laugh at the trial of the innocent. The earth is given into the hand of the wicked. He covereth the faces of the judges thereof. If not, where and who is he? Now my days are swifter than a post. They flee away, they see no good. They are passed away as the swift ships, as the eagle that hasteth to the prey. If I say, I will forget my complaint, I will leave off my heaviness and comfort myself. I am afraid of all my sorrows. I know that thou wilt not hold me innocent. If I be wicked, why then labor I in vain? If I wash myself with snow water, and make my hands never so clean, yet shalt thou plunge me in the ditch, and mine own clothes shall abhor me. For he is not a man as I am, that I should answer him, and we should come together in judgment. Neither is there any daysman betwixt us, that might lay his hand upon us both. Let him take his rod away from me, and let not his fear terrify me. Then would I speak, and not fear him, but it is not so with me. Job chapter 9. And even though, we think that our problems just go on and on and on, if we give it to God, He'll work it out. He'll work them out for us, and He'll walk us out of whatever we were doing and into what He wants us to do, if we allow Him to, and allow Him to do His will in our lives. Allow Him to express through us. So if you haven't given your life to Jesus Christ, I highly recommend it. I hope everyone has as good a week as possible. I love you all, and I'm praying for you. And I hope everyone has a good week and a good Thanksgiving, and that there's peace in your lives and in your hearts, and love. And until then, I love you and I'm praying for you. Speak to you next week. God bless you. Go in peace, and good night.